Right now, 24 billion kilometers from where you're sitting, a machine the size of a small car built in 1977 is still talking to us, and we're still listening. September 1977, NASA launches Voyager 1 on what was supposed to be a 4-year mission. Scientists had spotted a once-in-175 years alignment of the outer planets, a gravitational slingshot opportunity that would let a single spacecraft visit 4 planets in one trip. They couldn't pass it up. The computer on board had roughly the power of a pocket calculator, less storage than a modern MP3 file, and they sent it to the edge of the solar system. But here's what nobody tells you. Voyager wasn't even supposed to reach interstellar space. So how did a 47-year-old probe end up making one of the greatest scientific discoveries of the century? The flyby results were staggering. Jupiter's moon Io was volcanically active. Nobody expected that. Saturn's rings turned out to be made of billions of ice chunks, each one with its own orbit. The mission was a triumph, and then they just kept going. NASA extended the mission, then extended it again. Voyager kept flying, kept sending data, kept working against all odds. Our sun doesn't just give off light and heat, it constantly blasts out a stream of charged particles in all directions, called the solar wind. This solar wind creates a giant invisible bubble around our entire solar system. Scientists call it the heliosphere. For decades, nobody knew exactly how big it was or what was beyond it. Voyager gave us the answer. In August 2012, after 35 years of traveling, Voyager 1 crossed the heliopause, the outer boundary of our sun's influence, and entered interstellar space, true interstellar space. It was the first time in human history that any object we created had passed beyond our solar system. And the signal it sent back when it crossed that boundary, it took 17 hours to reach us. 17 hours traveling at the speed of light. Let that sink in. Here's what interstellar space actually is: almost nothing. It's not the vacuum of space between planets, it's something even emptier. Fewer particles, different magnetic fields, and a strange hiss of plasma that Voyager detected the moment it crossed over. Scientists call it the interstellar medium. Voyager is the first thing we've ever had out there, measuring it in real time. Every measurement it sends back is genuinely new information. We've never had a sensor out there before. Voyager is a pioneer in the most literal sense of the word. But here's what makes this even more remarkable. The probe itself is still functioning after 47 years. It's powered by the heat of decaying plutonium. Each year, it gets a little weaker. Engineers have had to turn off heaters and instruments one by one just to keep the most critical systems alive. In 2023, something alarming happened. Voyager 1 started sending back garbled data. Scientists back on Earth spent 5 months diagnosing the problem across 24 billion kilometers and fixed it with a software patch. A software fix on a probe built in 1977. That's the engineering equivalent of performing open-heart surgery on a patient using a phone from 1977. So how do they actually talk to it? The antenna on Voyager is only 3.7 meters wide. The signal it sends us is 23 watts, less power than a fridge light, and we can still hear it. How? The answer is the Deep Space Network, a system of enormous radio antennas positioned around the world. Each dish is over 70 meters across. Together, they catch Voyager's signal, a whisper from 24 billion kilometers away, and amplify it into data we can actually read. Every single day, these dishes point at Voyager, and every single day, Voyager answers. Voyager also carries something extraordinary, a golden record. Chosen by a team led by Carl Sagan, it contains 115 images of Earth, greetings in 55 languages, music from every culture, and the sounds of our planet: wind, surf, rain, a mother's first words to a newborn child. It's a message in a bottle, thrown into an ocean with no shores. Right now, Voyager won't reach another star system for another 40,000 years. The nearest star to our Sun is over 4 light-years away. Even at 17 kilometers per second, Voyager's current speed, that journey takes longer than our entire recorded human civilization, multiplied by a factor of 10. Carl Sagan once said, "Look again at that dot. That's here. That's home. That's us." He was referring to a photograph Voyager took of Earth from 6 billion kilometers away, a photograph we asked it to take as a parting gift. In that image, every human being who ever lived, every city ever built, every war ever fought, it's all on that pixel. Voyager is our furthest outpost, our longest handshake across the dark. Scientists estimate it will keep transmitting until around 2025 to 2030, when the power finally runs out. After that, it won't stop moving. It'll just go silent, a message with no sender, drifting forever. A 47-year conversation, still ongoing. If Voyager's story gave you chills, you're not alone. There are 2 more spacecraft out there that don't get nearly enough attention, including Voyager's twin, Voyager 2, which took a completely different path. Hit subscribe, and we'll take you there next.